We are here today to talk about the benefits of IPCO's steel belt in the digital printing industry. I'm welcoming Sherilyn Garcia-Lindgren from IPCO and Lauren Blasius from Fraunhofer IPT. IPCO involved Fraunhofer IPT to analyze the belt characteristics of plastic and steel belts on a test bench in Aachen. But let's begin by introducing the company. Sherilyn, please let us know a little bit about IPCO and its history.
Certainly. IPCO, formerly Sandvik Process Systems, they have been manufacturing steel belts for well over 100 years. They have led the way in terms of innovation ever since they introduced the first steel belt to the industry. Early applications were areas where the strength of the steel was important, particularly in conveying. Other properties such as thermal conductivity, that is the ability to transfer heat, opened the doors to new applications within food and chemical processing. So basically, IPCO has been producing numerous steel grades for different applications. Thicker belts for heavy machinery, such as presses, for the production of wood-based panels. Ultra-wide belts, up to 8 meters wide, for calandering and drying of paper in paper machines.
What about belt quality? What are the special characteristics of a steel belt?
Flatness, straightness, thickness are all essential in a steel belt, and that is why we are investing in a new facility in Sweden to be able to cope with future demands. Advanced manufacturing techniques mean that we can produce steel belts to extremely tight tolerances, and we can apply custom-made surfaces to special applications such as film casting. High-quality digital printing is dependent on a number of factors. Among others, precise positioning of the substrate, that is the product to be printed on, in relation to the printer heads. Our steel belts can now be produced to tolerances measured in fractions of a micron and are able to deliver this precision. Importantly, unlike plastic belts, they don't stretch, so positioning is fully controllable.
You explained earlier how IPCO can produce steel belts of exceptional straightness and flatness. Is that the key benefit of that?
It's important, certainly, but the major advantage in digital printing is stability, especially at higher speeds. Getting the most out of your printer means running at high speeds, but this brings with it risk for vibration and loss in quality. And to keep the steel belt in position during operation, we've developed an advanced tracking system, specifically for higher speeds.
At this point, I would like to bring in Lauren Blasius from the Fraunhofer IPT. Fraunhofer is one of the world-leading applied research organizations. And Lauren, you carried out tests to compare the performance of an IPCO steel belt and of a plastic printing belt. Can you tell us how you did this?
Of course. We develop and build customer-specific machines and test stands at our institute. In this particular case, we built a test stand to analyze conveyor belts in various aspects like vibrations and fatigue strength analysis. In the first step, we analyzed levels of vibration for the steel and plastic belts. We used laser sensors to measure the movement in the y-axis up and down on both belt types with belt speeds between 30 and 300 meters per minute. We also looked at the performance of steel belts under different levels of tension.
And what did your test reveal?
We analyzed the vibration relating to amplitude range and standard deviation. The first interesting result was that the vibration was at its highest at low belt speeds and at its lowest at high belt speeds. Let's have a look at the results in more detail. We increased the belt speeds in steps by 30 meters per minute. At belt speeds of 180 meters per minute, the amplitudes of the steel belt ranged from 60 to 90 microns, while the plastic belts were around 300 microns. At the highest belt speed we measured, at 300 meters per minute, the vibration were even lower, The steel belt ranging from 30 to 50 microns, while the vibration of the plastic belt were around 200 microns.
Those are substantial differences. Did your research reveal anything else?
Yes, you're right. The difference in performance in terms of vibrations of the belts is significant. The plastic belt showed around 3, 4, or in some cases even 5 times higher vibrations than the steel belt. Some of the highest amplitudes of the plastic belt were measured particularly at the point of its seam, whereas the welded join of the steel belt is virtually invisible.
Sherilyn, can you tell us how this affects the printing quality?
The study is still ongoing, but with such significant differences in vibrational levels, we expect that this will visibly reflect on the printing results. So stay tuned, there's more to come.
There must be a huge potential for a tool that can deliver these kind of benefits. What opportunities do you see for IPCO steel belts in the digital printing industry?
Well, most interest we've had so far is concentrated on the wide format applications. Typically, corrugated board, folding box board, retail carton board packaging, and the like. Thick plastic film wraps, furniture board, ceramic tiles. And we believe that with IPCO steel belt, together with our advanced tracking system, high-speed, high-precision digital printing is possible.
Sherilyn and Lauren, thanks for joining and have a good day.
Thank you.